This video we are going to talk about the dative covalent bond. Before we learn how to draw a dative covalent bond, first of all we have to know the definition of a dative covalent bond. For a normal covalent bond, it is formed by sharing of outermost shell electrons between two atoms. Each of the atoms have to contribute the same amount of electrons, forming the sharing pair. But in a dative covalent bond, it is different. First of all, it is a type of covalent bond, but it's formed between two atoms. But this time ago, where the both electrons of the shared pair, they are not contributed by both atoms. Instead, they are contributed by the same atom. So the key point goes to here, contribute by the same atom. Both electrons of the shared pair are contributed by the same atom. So this is the features of a dative covalent bond. So you'll find that in this covalent bond forming, there are two parties. One which have a lot of electrons, while the other ones have no electrons. So the richer one will then donate both electrons to the one without electrons. So have a look of examples right here. So this one is a very typical ammonium ion with dative covalent bond. So you'll find that at this point, this one, the highlighted one, this one is a dative covalent bond. Originally, it's coming from the electrons coming from the nitrogen. If you know that the nitrogen originally is look like this, ammonia. And then you find that, okay, it have a lone pair electrons outside, and then an hydrogen ion, it should be an ion without any electron in the outermost shells. So this lone pair electron then contribute, okay, to form the dative covalent bond and share with the hydrogen. So in this diagram, you can see that the nitrogen itself, they got 8 electrons in the outermost shell, while this hydrogen can also share 2 electrons, which fulfilled the outermost shell, the first shells of the hydrogen. So therefore, this form a dative covalent bond. So in this sections, we're going to learn 2 typical examples. First of all is ammonium ion, just how we mentioned. So we will have a ammonia ion, and then they have a lone pair electrons, while the other one, okay, will be hydrogen ion. For hydrogen ion, okay, you know that hydrogen is H11, where they got 1 electrons. But once they lose the outermost shell electrons, this hydrogen atom will just have a protons in it only, okay, but without any electrons. So you find that in the first shell, actually, it is empty, okay. But the nitrogen have a lone pair electron, so therefore it can share to the hydrogen. So therefore, when they combine, you will see the lone pair of the nitrogen can contribute to the hydrogen. As the hydrogen itself, okay, it is positive. So these two things add together will still be positive. So this is how we draw a dative covalent bond. If it's in a electronic diagram, or if it's in a dot and cross diagram, things it will be like this. The nitrogen, hydrogen here, remember, this is a dot and cross diagram. So when you see a hydrogen, no electron in it, this one should be positive. So this lone pair in the nitrogen can contribute to the hydrogen ion. So therefore, the nitrogen will form 4 covalent bonds. But among these 4 covalent bonds, one of them, both electrons are contributed by the nitrogen, like this. And overall, there is a positive charge right there. So you can see that, okay, when we draw like this, you can find that this one will be the dative covalent bond, okay. But you have to notice that, okay, ammonium ion consists, this ammonium ion, okay, they not only consist the covalent bond, but also it form an ionic bond because you got a charge right there. Okay, so typical ionic compound, it will be like NH4Cl, ammonium chloride. You got a cation, you got anion, and then you got covalent bond in it. Second things I want you to pay attention to, and very, very important, which is for these 4 NH bond, these 4, 1, 2, 3, 4, okay, actually they are identical, they're exactly the same. You may ask, okay, why they are the same? The dative covalent bond is formed by the electrons contributed by N, okay, while the others, they are contributed by N and H, both of them. Okay, actually the formation process is different, but once they are formed, okay, the dative covalent bond cannot be distinguished. Okay, they cannot be distinguished from normal covalent bond. That means after they form 4 bonds, actually they are the same. Okay, so this is the first one that you have to know how to draw ammonium ion. Second one, okay, common example that will be hydronium ion. So this H3O plus, actually it is forming by a H2O plus and H plus. Okay, so for a H2O, so you got H2O like this. Oh, sorry. So you got H2O like this. So you find that this H2O have 2 lone pair electrons. So actually in the outermost shell it's quite rich. Okay, you got 2 electrons there. Okay, when it's C and hydrogen ion again, okay, this one is very, very poor, have no electron in it. So the lone pair electrons right there can contribute to this one, okay, forming hydronium ion. Okay, so remember, use dot and cross diagram. So this one will then be having a cross. Okay, so this will be the dative covalent bond. This will be the dative covalent bond. However, remember, when they form together, actually you can't distinguish which one is normal bond, which one is dative covalent bond. But when you draw, okay, you can tell. Okay, so this one, okay, is the electronic diagram. If you draw a structural diagram, then it will be like this. I prefer to show the lone pair. Okay, but sometimes in textbook you find that, okay, they didn't draw this cross. Okay, that will be fine as well. Okay, so I draw like this way, then you easily know that the lone pair will contribute, okay, to a dative covalent bond. This symbol, it represents the dative covalent bond. This symbol represents the dative covalent bond. Okay, so next slide we're going to show a few more examples, but before you listen to me, actually you can pause the videos and then try to draw it out by yourself first. Okay, so let's have a look. Okay, so other example that you may have, okay, it will be BF3NH3. So this one, just draw a simple version. So, okay, the dative covalent, the electronic diagram one, I will skip it. So you got, actually you have BF3 plus NH3. Again, okay, NH3, the lone pair electron is right there, okay? So therefore it can contribute to B. If you pay attention to B actually electronic configuration is 2, 3. So even they form 3 covalent bond, maximum in the outermost shell is just up to 6. Is that right? Because you got 3 extra electrons from the F. However, okay, it will just up to 6, from 3 to 6. Still, okay, it doesn't obey octet rules. So therefore, BF3 actually is quite unstable because you have electrons deficient. Okay, not enough electrons in it. So the molecule will then be like this. This one have no electrons, but N, okay, they have lone pair electrons, so it can contribute to B. Okay. While BF4, okay, it is coming from BF3 again, okay, the one who's a lack of electrons, and then it's CAF minus. So remember, F is 2, 7. So F minus, actually, it is 2, 8. We have 1 extra electrons. So this one actually is quite rich. We have a lot of electrons, but B is not rich. Okay, so therefore you have BF3. This is the electron deficient one, okay, while the F minus, okay, we have a lot of electrons around it. Okay, so this one have a lot of electrons in it, so therefore it can contribute to it. Okay, so for this one, okay, you draw like this: B, F, F, F. Because it's the F contribute to the B, so therefore the arrow draw like this way, from the F to the B. Okay, from the F to the B. So this one is the dative covalent bond. So 2 more examples. So one will be carbon monoxide. Carbon monoxide is a complicated example, so you can have a look right here. So you got C and you got O. Okay, C and O. Oh, so the C, okay, will have 4 electrons in the outermost shell. So they can form 2 right there. So like this. Is that right? So you find that right now on the right hand side, oxygen have 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Have 8 in the outermost shell. However, for C, they just have 4 plus 2. Okay, so you find that C actually it doesn't obtain the octet structures. So therefore, the O actually it can contribute this extra 2 electrons right here. So instead of drawing the outermost shell like this, okay, the extra 2 electrons it can be put here. Okay, so at this moment you can find that okay on the left hand side you got 8 electrons, right hand side you also got 8 electrons. Okay, so the structural formula how we draw that, okay, we can draw like this. We got a normal double bond, but at the same time O will also contribute 1 to C. So therefore the dative covalent bond can draw like this way. Okay, so this part, okay, this is the dative covalent bond. Okay, this is a dative covalent bond. Last one is the ozone. Okay, ozone. You got 3 O right there. So 1, 2. Normally, okay, for the oxygen, they form a double bond. Okay. Oh, sorry. So you form a double bond right there. Okay, double bond. So right now on the right hand side, you got 1, 2, 3, 4, and then you have 4 here, 8 electrons. 4 and then 4 electrons, 8 electrons. So this one is stable at this moment. But for ozone, okay, actually it's an O2 plus an O. Normally O is lack of 2 electrons. So in this case, what we have to do, okay, we just put an O right there. So you'll find that this O need not to contribute any electrons. But for this O, okay, they can use the lone pair, okay, to share with this O. So this O, you can find out 1, 2, 3, 4, 5, 6, 7, 8 with 8 electrons there. So to draw a structural formula, it can be like this: O, O, okay, and then contribute lone pair electron to the other O. Okay, so these 4 examples, they also contain a dative covalent bond in it. So to summarize, okay, dative covalent bond actually it contain is a covalent bond, first of all, formed between 2 atoms where both electrons, okay, of the shared pair are contributed by the same atom. So some keywords like contribute, same atom, both electrons, okay, it must not be missed, okay, in the process. Example, okay, in the textbook, okay, we got 2 of them. So in the textbook, okay, we focus on ammonium ion and also hydronium ion. Okay, you must know how to draw these 2 type of diagrams. Okay, while the other ones, okay, are the example that are given by me, it will have like carbon monoxide. This one BFNH3, you got ozone and also BF4. Okay. Miss out a F right there. Miss out F right there. Okay. So that's all for this video. Bye bye.